Boom. There we go. We are live. It is Friday, June the 7th. Okay, so I've done a couple of videos recently that were, I want to call them hard hitting, but, once again, it's just truth bombs, right? It's just me trying to be as truthful and honest as I can be. And as I talk about these things, I just can't help but recognize that our species is wading into territory that I'm just going to have to talk about. I'm just going to have to talk about it. A lot of people have brought it up. Guy McPherson kind of made a name for himself starting about 10 years ago, it feels like now, about talking quite frankly and seriously and scientifically about what he was calling near-term human extinction. And I think that's the best term for it. So I don't talk about that too much. Spoiler alert, I don't think that humans are going to go extinct, but I think it can be argued. And since it can be argued, since there is a scientific consensus emerging on this topic, and since it is a topic now kind of making the rounds, I just wanted to kind of get out in front of that. I think the prospect, or I should say the topic of near-term human extinction is going to erupt into the zeitgeist, the shared discussion fairly soon. Okay, so I don't want to get ahead of myself. I'm going to do what I think are probably 3 videos. It's at least 3 topics, and I'm going to try to keep these short and fairly digestible. Well, as usual, I'm off script. I don't have any guidelines before me, except scientific principles, right? That's pretty good. So we're going to stick to science. This is not going to be science fiction. It's not going to be emotional hyperbole. I'm not a preacher. I'm not a damnation preacher going to talk about hellfire and all this kind of stuff. I'm just talking about near-term human extinction. It's a scientific thing. Either it's possible or it's unlikely. If it's going to happen, then there's a way it's going to happen. There's steps through extinction. We know this really well. We know what the steps are for a group of similar organisms, species, to go extinct. We know what's required. We know what leads to that. We've biologists, scientists, naturalists have been studying extinction for hundreds of years. And of course, we have colossal examples of extinction found in the fossil record. For example, the 5 prior extinction events that we know of are recommended, that are realized in the fossil record. One of the big ones, and one of the more recent ones, was the extinction of the dinosaurs, right? The dinosaurs went extinct, probably all pretty much at the same time, certainly within a short period of time. And we don't know. We have a good idea what caused that, and that was, the Chicxulub meteor. So, we know about that. Oh, and by the way, it should be mentioned at the outset that we are now, according to naturalists, biologists, and people who think about these things, we are now, this planet is now, it's not really we, the planet is now experiencing what they're calling the 6th mass extinction. I'm not going to talk about that much, but it's part of the topic today, right? So today I'm going to talk about specifically what extinction is, because there's probably some confusion about that. Hollywood hasn't helped much. The plight of the dinosaurs probably hasn't helped much, or maybe it helps. You will be the judge of that. And there's a lot of emotion around it, and you don't have to be emotional about it. Extinction is a thing. Happens all the time, really does. And most of the extinctions recently have been caused by humans. We've been doing that. We're kind of in that business, right? So, we are the creators of extinction events. And now the question is, are we going to be subject to one? Fair. That's one topic. What is extinction? The second topic is going to be broadly why that might apply to us. So I have to talk about what extinction is so we're all on the same page. But then I want to jump right to, why does that happen? In what way are we now vulnerable to this? Why does that apply to us? Is there a reason why people are talking about near-term human extinction? Is there math behind it? Is there sound science, research? or at least logic. Why is this a discussion? And why will it be even more of a discussion in the near future? And why am I bringing it up? I'm a scientist. I only talk about sciencey things. So, if near-term human extinction is just a meme, right? Just fodder for the doomer crowd, then maybe I don't have to talk about it. Except I think it is a real thing. Near-term human extinction is a thing. It is a thing. And then the third part of the three will be how it happens, how humans go extinct. And I'm going to talk about extinction. Okay, back to the first topic. So that's the outline, right? That's the outline. 3 videos are coming. I'm going to label them parts 1, 2, and 3, and I'll try to get to them all in order. There's even a possibility I do them all today. My wife would hate me if I spent so much time on here doing that. But I think it's got to be done. I'm a science educator. I'm a scientist. I'm a biologist, an engineer. I've been studying this whole brouhaha about climate change, as they like to call it, or more specifically, correctly, accurately, global heating. And yeah, that's going to be a real shit show. Okay, that's going to be a real problem. And if people are already talking about near-term human extinction, then I should address that. Either say, nah, or say, okay, maybe. And, either it is or it isn't science, right? There either is or there is not science of near-term human extinction. Okay, well, spoiler alert, there is. There is science. There is a science about how humans would go extinct based upon current events. I don't mean another Chicxulub meteor, right? There are things happening in our world right now that are causing people to think about the prospects of near-term human extinction. So let's go there. Before I get started, if you like this kind of content, please definitely subscribe. Once again, there's going to be 3 parts to this. If you don't want to miss any, maybe you want to miss them all. I don't know. Bye. It was nice knowing you. Thanks for visiting. Thanks for watching. But if you do want to see the rest of it, well, then you may want to subscribe to the channel, because I'm telling you, man, it's getting real out there. And as it starts to get real out there, I'm bringing it home. Okay, and we're gonna talk about this. It's all science, as far as I'm concerned. It's all physics, and near-term human extinction has a actual basis. So we're going to do that. Also, like the video. It helps with the algorithm, helps me get out there to terrorize and infuriate more people. And I just created a buy me a cup of coffee account. My wife is noticing how much time I spend doing this, and so it would make it easier for me to do this if sometimes you people bought me a cup of coffee, right? And then she would, it's a lot easier for me to spend my time in here if you people are paying me to do some of this. So definitely give it a thought. It's a lot of time for me to sit here in front of this camera when I actually do have other things to do. And it's hot outside. And if I don't get to it early, instead of doing this, then whatever. So give it a thought. Subscribe, like, buy me a coffee. Let's go. So the topic, near-term human extinction. Let's talk about extinction writ large. Has to be said. I'm going to say something right away, just to kind of up the ante here, right? To have some buy-in here. Humans almost went extinct already. True. Most people don't know about this. This is one of those esoteric parts of science that in fact came out of the Human Genome Project. The Human Genome Project was way, way, way more important than people think it is. And when we started digging around in the human genome, the human genetic code, right? And I have mine, and my wife has hers, and our children got theirs from us. That's how reproduction works. And you have yours, and the people that you meet in the street, they all have their different their own different genetic material. Well, when the Human Genome Project started studying the human genome, the genetic material we all share, rent, borrow from each other, then they discovered something mathematically that was really interesting. And that's why we do basic science, is so we can discover interesting things. There was no evidence in the outside world of the human world that humans had almost gone extinct. There was nothing. And then when they started digging around, they started looking at at the data, one of the questions they asked was, so how long have people been around? And so I'm going to be throwing all kinds of science at you, right? I'll be talking about extinction, but I'm also going to talk about why we know some of the things we know. It's science, it's math, okay, it's physics. It's just I'm not blowing smoke up your ass. I'm not just railing against humanity and they're so stupid and they're all poopy heads and they're all going to go extinct because they're poopy heads that won't listen to me and do what I want. That's not what I'm doing here. Humans almost went extinct. Fact. It's a fact. It's a fact that came out of the Human Genome Project. They looked at the genome and they said, wait, this can't be right. Look at some more genomes. Wait, it's still the same. Hold on. Now we have a problem here. What's going on here? Humans have only been on the earth for 70,000 years. What are you talking? That's not true. We have modern human remains, stone tools, the whole thing. Modern human remains, modern skulls, modern jaws, all the things that make us human. Upright walking, valgus knee, the whole thing. I mean, there have been a lot of humanoid creatures, right? But modern humans, this, that, right? Little nose, the whole thing, the whole modern human thing has been around for 300,000 years. And yet, it seems like if you look at the human genome, we've only been around for 70,000 years. So they had to go at this, right? They had to really study the hell out of this. Like, okay, something's wrong. Oh my God. And the first thing they thought was there was something wrong with their math, and there was something wrong with their research, and there was something wrong with the Human Genome Project. And what is wrong? We've done something wrong. Hell, we thought we were doing the right thing, but now it's all screwed up because when we actually date the human genome, which they do through mutation rates and a bunch of other things, which is just math, it's just math, it's just statistics, they found out that humans are basically 70,000 years old. And then someone came along and said, well, you know, there's a way that that could happen. I'm listening. Do tell. You mean our research isn't completely screwed up? You mean we didn't screw the pooch? How can humans be 70,000 years old when there's fossil record going back 300,000 years? Well, we may have almost gone extinct. That works. Whoa. Hey, that works. Because look what happens. Populations begin as a few individuals, right? That's how evolution works. Populations of a distinct genetic profile, humans, start as a few individuals. And if that works for them, if their survivability in the habitat they find themselves in is enhanced by their genetic component, right? Then those populations get bigger and bigger and bigger. And so you get the thought, it's not true, but I'm going to use it anyway. There's a kind of a genetic Adam and Eve. And it's not. It's always a group of some kind, and then the group begins to survive, and the group becomes a bigger group, and then there's more groups, and they're everywhere, and they're a planetary species. But there's sort of a concept of a genetic Adam and Eve. They don't even have to be together. They could be, Eve could be over here, and Adam's way over there, and they're separated by hundreds or thousands of years. But somewhere in the mix of all the human-y things that made us eventually, Homo sapiens, there was a genetic Adam and a genetic Eve, and we all kind of came from that cloud of possibility. By way of saying, there was a few of us that became all of us. And that's just kind of how it works. And that story, that rich history of becoming is written on our DNA. It's written on our DNA, and not just the DNA of me and you and all the people we pass on the street. There are people that live in Asia, and they have a slightly different story than the people who still live in Africa. And they have a slightly different story than the people who made the long, long trip to the Americas. And so the history of all these groups, after they separated from each other, they had their own history. And of course, some of that is actual history. I mean, the Asians have a completely different history. They didn't have a Middle Ages. They didn't have the Black Death. Asians didn't conquer the Americas, and the South America and the Inca gold and all that. The Asians didn't do that. They have their own history, and it's rich and it's full of invention and innovation. They came up with paper. They came up with gunpowder. They came up with a lot of things. And we got them in the West, and then their history became our history. The histories overlap, but they had their own. They had their own history. And that history, apart from the gunpowder and the paper, the history is written in their DNA. And the people in North America have a slightly different history written into their DNA than the people in South America. And the people in Africa have the best history ever. The people in Africa, where this whole thing started, their line of history is amazing. There's more genetic history in one village in Africa than in the entirety of Europe. And you think the French are different than the Germans, are different than the Scandinavians, are different than the Rus, that are different than the Spaniards, different than the Italians. They're all essentially identical compared to one village in Africa, where the history of everybody began. All of this diverse history has its roots, its rich, fertile, deep roots in Africa. And one village in Africa has more genetic history than all the rest of this stuff combined. We came from that. But the problem is, we almost died. All of us almost died. We've been on the planet for 300,000 years. And yet, when you look at the history of all this, and you trace that history back, and you look at the genetic modifications, you look at the genetic structure and all the writing and all the story being told in the genetics itself. And I'm not going to go into that. You may want to if you're interested in it, but the rate of mutations and tracing it back and all of this convoluted history, and it all comes back to the same trunk, all comes back to the same root, and all comes back to the same set of individuals, and that was 70,000 years ago. We almost went extinct. We almost went extinct. We lost. Everything was pruned away 300,000 years ago, up to 70,000 years ago. That entire written history, written in our DNA, was lost. Poof. Gone. Except not quite, because there were some individuals around. We're going to call this group of males genetic Adam, and this group of females genetic Eve, and they were all able to find each other and reproduce, and they kind of kept it going, okay? But that small group of people, and I've heard estimates from like 2,500 individuals, so half males, half females, right? 2,500 individuals, up to maybe 10,000. That we went through what's called a genetic bottleneck. However many people there had been on the planet before, we got squished down to a few thousand. Now, that's not extinction. And we need to understand that right up front. That's not extinction. That's called a die-off. Still a big deal. I mean, okay, let's just realize this right now. Let's just wrap our head around this. A big die-off down to a few individuals, maybe a couple of hundred or a few thousand. Yeah, that's kind of scary. But that, even though that's not extinction, if it were to keep going, what's at the bottom of a really serious die-off? At the bottom is none. Now, even then, it isn't none. We have to really be careful talking about extinction. There's two reasons why a species can go extinct and the number at the bottom of a die-off not be zero. That species can still go extinct. Here's one reason, which actually can lead to a complete extinction where the result is zero. You can have all these individuals, the females and the males and whatnot, but if they can't find each other, the females can't find the males and they can't reproduce. Or if they can reproduce, but the offspring die, they fail to thrive. So maybe whatever's been killing all the adults also kills all the offspring, right? So if either they can't find each other, you can have thousands of individuals of a species, but if they can't find each other or they cannot successfully reproduce, then, okay, the species isn't extinct because there they are. You got one here, you got one there, and that's two at least, and that two is enough, right? But because they can't reproduce, then when those individual elements of the species do die of old age or predation or falling over a cliff or whatever, get eaten by a tiger, then the species goes to extinction. But they were already what we call functionally extinct. They were functionally extinct, even though they were walking all over the landscape. They were essentially extinct because they couldn't reproduce. So if you have the last few of a species and they're all being kept in zoos, then they can't find each other. Sure, you can go to the zoo and you can look at them and you can and you can say, "Oh, look, isn't that nice?" I heard that's a rare animal. But if the animals in the zoos can't find mates, or if they can find mates, but they nevertheless, for whatever reasons, and there's usually lots of reasons why this happens, they cannot reproduce, then they're functionally done. It doesn't matter that there's actually that animal, that panda, that walrus, that whatever, that you can go to the zoo and look at and say, "Oh, isn't that cute?" and go to the next grotto. That animal is functionally extinct because unknown to you, and maybe even unknown to anybody, that animal is not reproducing. Either it can't find a mate, or it can't successfully reproduce, or something is missing and it's done for. And this can happen, I'm talking about animals, but this can happen to plants too, because plants have to reproduce. And you can have a plant growing someplace that maybe has lost its pollinator. This was a story in Hawaii. They found some plant and they couldn't figure out, it had a really strange looking flower and they couldn't figure out what its pollinator was, and the plant wasn't reproducing, and they never found the pollinator. And they kind of, because of the shape of the flower and the way the flower would open at night, they kind of thought, well, it must be a moth. Pale flowers that open only at night, they're either being pollinated by moths or bats or some combination of things at night. Okay, so in this plant, it was growing on the cliffside. It would open its light-colored flower at night. The moon would shine down. The flower would be visible, and they never found a pollinator visiting that flower, and the pollinator was gone. Now, with plant, so that plant is functionally extinct. It's not going to make fruit. Maybe once in a while it will if it self-pollinates. And sometimes these plants, and this is much more common in plants than animals. Animals generally don't do this, but plants can become self-pollinating or self-fertilizing, especially if they've lost their pollinator. So there's a certain amount of evolutionary pressure, and there's some Darwinian natural selection going on. And pretty soon there's a plant that looks like the plant, has the flower like the plant, but all of a sudden there's this new mechanism, it's self-pollinating. Or maybe there's another pollinator that gets injected into the system. It says, "Oh, look, here's a flower that no one's visiting because it's full of nectar. So I'm going to visit this flower all the time." And all of a sudden there's a new pollinator that shows up. And so the plant, wipes its brow and says, "That was close," and now it can reproduce. So, but this can happen all the time. You can have plants that have lost their pollinator, that don't evolve self-pollination or don't find a new pollinator, that are functionally extinct. You can have animals where, they're not gone, but the mates can't find each other, and the offspring are not being produced, and maybe there's no habitat for them, or the food isn't right, or whatever the problem is, they can't produce offspring, and they're functionally extinct. So extinction is this, and this is going to be a theme throughout this series of talks I'm going to do. Extinction is it's not only a spectrum that some animals are not going extinct, some are closer to extinction, some are very close to extinction, they're functionally extinct, and then some are extinct. It's not just a spectrum like that. It's also a set of steps that happen on the way to extinction. That's the biology of extinction. It happens in a series of steps, and you can try to intervene at some of those steps, or you can prevent steps from taking place. Okay, but if you don't, then at the end of all those steps and all that progression and all the things that happened and weren't addressed and weren't fixed, and they never figured it out, and they never found a mate, and they couldn't reproduce, and the offspring died, and at the end of all that, they go extinct. And there's no real indication that that's happening if you're not studying it and you don't understand how extinction works. So as we discussed near-term human extinction, which other people are talking about, so I guess I'm going to talk about it. We have to always be aware that there's a set of steps. It's not something that happens overnight. And it's not something that happens to those people, but not you. That's not extinction. I mean, they're gone, they died, they whatevered, or they left, and now that landscape has no people in it, however you want to infer what happened. But the fact that you're not suffering, that means your species isn't going extinct at the moment that we know of. Okay, so Extinction is a science. It has steps. We know what those steps are. We know what causes extinction in plants. We know what can cause extinction in animals. We monitor animal populations. And when we monitor them, when biologists are out there monitoring animal populations, they're looking for things like how many groups of animals are there? If they're a solitary animal, how many solitary animals are there in a certain habitat? This is common with tigers, for example. Every tiger, male and female, has its own habitat. And the habitat range. Every male tiger has its own territory, and every female tiger has its own territory. Uh, where their territories overlap, they fight. You're in my territory. What are you doing? Get away from my territory. And they fight over it, unless the female is in her breeding season, in which case that when she comes to the edge of her territory and the male finds her at the edge of her territory, they fight, because that's what tigers do. They're fighting all the time. Whatever. They fight, but it turns into mating. And she'll stay around his territory, and they'll mate. And eventually, when she's had enough of him, or she feels like she's been fertilized, well, then she goes her way. And if he follows her, she fights him for reals. All right. And then he has to go back to his territory. So solitary animals, like in particular predators, even if they're out there separately and the male doesn't have a female and the female doesn't have a male, you have to study how they behave at the borders. And we know how tigers behave at the borders. And we, of course, because we know how the females find the males, because females have tiger cubs. What's that about? We've never seen her with a male tiger in her territory, and she's territorial. She fights the male tiger at the border. Oh, it's not always fight. Sometimes it's just for play. Sometimes it's just love taps. I mean, the fur is flying and the claws and everything else, but actually they're just getting along just fine. Thank you very much. And pretty soon she's pregnant. So this is really complicated. You have to really understand how animals survive, what type of habitat they need, what the behaviors are. If they're solitary, how do they find each other? And wildlife biologists spend entire careers answering these questions. And one of the reasons they answer these questions is so that they can determine how well the species is doing. How many tigers are there in the jungle? Are there as many tigers as this jungle could support, knowing how big their territories generally are? Are there missing tigers? Is there lots of tigers in this part of the forest and then there's none in this part of the forest? Okay, that suggests there's something wrong, because normally an animal will fill its entire range, just fill it all up. That's what they do. Well, the way tigers do that is the young tigers, when they grow up a little bit, the mother starts bapping them around, telling them, get the hell out of here, get your own territory. And so they wander around until they fight and they argue among themselves until finally they find a part of the forest where no one's beating them up. And they say, okay, this is mine. Anybody comes in here, you're going to have to, I'll beat you up. So if you find a part of a forest or a jungle where a predator or some kind of solitary animal is just not there, that suggests that there's a problem, that either they're not reproducing, or the young can't find this part of the forest, or the population in general is just shrinking. And while there might be a male over here by himself in his territory, when it comes time, when he's going to look for females, right? He's going to go looking for females. So pretty soon his new territory is right up against the territory of a known female that he found. So all the tigers end up being in one spot, because they need to be in contact with each other at the right time. And then this other part of the forest is empty. Why? Well, we wouldn't know that if we didn't do, wildlife biology. And we know how this works. And when they say things like, well, the tigers are endangered, what they're saying, that's a way of encapsulating decades of work on tiger behavior. And what they're saying is there is habitat that should have tigers, but there's none in there. Or there are females that should be having litters of cubs, and they're not. And there should be young tigers all through this forest, arguing over territories and finding their own place to live and establishing a turf and patrolling the borders, but there's not. Where are the young? All we see are old tigers. And when they study it and they say the tigers are endangered, that's what they mean, that the tigers are going through the steppes. They're going through the steppes. All right. Plenty of habitat, no tigers. Plenty of males, no females. Males and females, but no young. And empty habitat because the young aren't finding places to live. And you sense the steps they're going through, until finally, at the end, you go out there looking for tigers and they're not there. The males aren't there. The females aren't there. They're just not there. Or you find one. You find one male. And okay, well, there's a male tiger. Oh, that's great. Good to know. Wow. And then you go looking around and you don't find any females. And then you're really worried. It's like, oh, wow. Okay, we've got a male tiger, but what's he going to do? We got to find some females. And you don't find females, or you find females and no males. And now you start to understand why the females haven't been having litters, tiger cubs for a decade or two. And you're just like, oh, wow. Okay, well, answer that question. There's no males. And so we study organisms to see how they're doing. And if we suspect that they're in danger of extinction, it's because we've determined that they're taking the steps. They're on that journey. Nothing is working for them. The individuals may be well fed and healthy and they look good and they're protecting their territory, but they're just individuals and they're not finding each other and they're not reproducing. So this whole science of extinction is what we have to apply to humans, near-term human extinction. If that's our fate, it's because we are going to go through the steps. This didn't work. That didn't work. This other thing didn't work. And that's one of the ways that organisms go extinct, is they just can't figure it out. And the thing they have to figure out every single time is reproduction. Finding each other as mates, mating correctly, the females getting pregnant. We're talking about animals, and the young being born, and the young being healthy, and the young being fed and reared to adulthood. And by the time all that has happened, mating, gestation, birth, rearing, by the time all that has successfully happened, and you have new adults, then you can say, okay, success. But all that has to happen before you can say, okay, they're doing okay. They've got new adults. But if anything breaks along the way, the cubs aren't born, the cubs die after birth, the cubs can't be fed, the mother can't create enough milk, the cubs starve to death. If anything bad happens and there's no recruitment, as we call it, then they're taking the steps. They're just heading towards extinction. And in a different part of this series, I'll talk about, are humans taking those steps? Are they? And that's what I'm setting up right now. I'm setting up that discussion. So another thing that happens to animals that they go extinct is there's some new predator or parasite, which is not the same thing, but it ends up can have the same effect. There's a new predator or new parasite or a new competitor. I'll even allow for that gets introduced into their habitat where they live. And it either eats them all, outcompetes them, so they can't get food and water and whatever they need, can't get mates. Or if it's a parasite, it just destroys them from inside, which is almost the same thing. A parasite can make if an organism, and again, I'm talking about animals here. I should talk about plants also. But we're animals, and so animal extinction is more interesting to us, and it's more complicated. And in some ways, it's actually easier for it to happen. So that's the realm that we need to be more cognizant of. So if an organism gets a heavy load of parasites, then it's like, and the parasites are consuming the organism from inside. It's a bit like being eaten from outside. It's a bit like being caught by a tiger or a lion or a hyena or something and being killed and devoured. So an organism can be either hunted by another organism, or in the case of plants, herbivores, it can have a competitor, which maybe eats its food so that it has no food and it starves, or can have a parasite. If these kinds of things happen, then an organism can go extinct. And it's generally much more dramatic than the extinction I already alluded to, which is the stepwise. There's a big population, it just gets smaller and smaller and smaller and smaller, and then they die. Predators, of course, can kill all of something, all of it, even though it's doing fine otherwise. Lots of herd animal, lots of mates, lots of offspring, everything going great. They're not going through the steps of extinction. They're just doing their best thing, living their best life. But some organism comes along and kills them all. And more recently, that organism is us. We do that. We kill all of things. I'll mention the dodo bird. which now is the, like the meme for stupid, right? Dodo birds are stupid, and that's why they went extinct. No, that's not why dodo birds went extinct. The dodo bird, which was on some island, humans discovered the island hundreds of years ago during all of that sailing the seven seas, right? We were discovering the continents and discovering the islands and generally discovering other people. But these were colonial powers, Portugal, Spain, Italy, England, and and some others. They were covering the oceans, discovering new places. And the men on ships, ship life was difficult. And so when they came to this particular island, they found there was a bird on this island, and they called it the dodo bird. And the dodos were a kind of pigeon. And you see pigeons all the time if you live in an urban environment, and if you live in a rural environment, you've seen doves, rock doves, mourning doves. They're all in the same kind of family. And pigeons, that type of organism as a family, tend to not be afraid of humans and tend to be fairly easygoing around people. The pigeons that collect around the park benches where people are feeding them, obviously that's the case. They'll fly, but they'll walk right up to you too, and they'll steal a French fry if they can. And so the dodo bird was a type of pigeon, and so they weren't particularly afraid of people. It wasn't that they were stupid; they're pigeons. Okay, and they were flightless. Oh, and they were big. And so when the sailors came to this island in the routine business of sailing and discovering things, they found the dodo birds and they said, "Hey, fresh food. When you're on a ship all the time, fresh food is great." So they just started eating the dodo birds, and pretty soon they ate them all. And there's some claims that, okay, actually it wasn't just the humans. Don't blame the humans. Don't cap on the humans. Come on. It was also rats. Rats came ashore with the humans, however that happens. Rats hide in the boats. And when the humans come ashore, they jump out of the little boats. And now they're on the island. The rats ate the dodos, ate the young. So the island was swarming with rats after a while, and they just ate the young right out of the nests. And again, these are flightless birds. So the nests are not up in trees. Not that that would stop a rat. But, so what happened to the dodo birds was a combination of a predator, two predators, humans and rats, and who knows what else, right? Cats, dogs, diseases. Who knows what happened to the dodo birds? And it wasn't because they were stupid. They were just an island species, and they weren't found anywhere else to speak of. So once we killed them all, they were gone. We just ate them all, and they were doing fine. They weren't going extinct. They were doing great. Who knows how long they'd been there? They'd been there. Well, if they were flightless, they'd been there enough generations to lose flight. So they were flightless, large flightless birds, and they were living on this island, and living their best life, and then they were all gone because we ate them, or someone ate them, or we all ate them. So that's what happened to the dodos. And that's one way that you can go extinct. Somebody eats you or eats all your offspring. And okay, if you can't successfully reproduce, and once again, it's not enough that you laid an egg and the egg hatched and you fed the offspring. Okay, that's not enough. That offspring, in the case of a dodo chick, has to grow up to become an adult that can then reproduce. And if it just so happens that all of your remaining offspring are males, then they don't reproduce without females. And so if the luck of the draw, you end up with a bunch of dodo bird adults, but they're all males, well, then that species is functionally extinct. They're done. So we don't know what happened to the dodo birds, if it was something like that, or if we simply, humans, just caught them all and just ate them like you'd eat a chicken, right? We don't know. No one knows. Nobody recorded it, but they're gone. Not their fault. They were doing great. We ate them. And there have been other mass extinctions that are occasionally attributed to humans. The loss of the North American megafauna. In North America, after the end of the last ice age, 18,000 years ago, there was an entire assemblage of large animals, that megafauna, that lived in North America. You can go to the Natural History Museum, and they'll have dioramas of those things. They might even have stuffed versions of them, great big huge animals. These are megafauna. They're big. And they were like mammoths, mastodons, ground sloths, Camels in North America? Horses? There were no horses in North America until the Spanish came and brought horses with them, right? And there was all these large animals that existed in North and South America, North America mostly, is what we talk about in this topic. And then they all disappeared. And they all disappeared at about the same time. And the ice age was ending, so they were like woolly mammoths are associated with the ice, and they were associated with the ice. And as the ice disappeared, they may have lost their habitat. Maybe if some part of their food supply was tied to the ice, and so as the ice retreated and their food supply retreated, it just they lost their food supply. Who really knows? But one theory is, at the time then the ice age was ending, humans were coming in. They were coming in from Asia, and about the time the humans showed up, the megafauna, the North American megafauna, went extinct. All of them, not just one type, all of them went extinct. And archaeologists and paleontologists, they look at that and they say, well, that's a coincidence. And other people will say, no, it's not the humans. It was just habitat loss. It was the end of the ice age, and they were dependent on something that went away, some other thing we haven't discovered, some plant or whatever. And, it wasn't the humans. Don't blame the humans for everything. Don't be a poopy head. Or maybe it was us. Could be. There used to be a megafauna in South America. I'm going on and on about this because I want you to understand. There was a megafauna in South America that wasn't mammalian. Okay, but it was birds. They had bird megafauna, and they had what was called terror birds, which is meant to be descriptive. Terror birds. They were huge. Birds are descended from dinosaurs. So if you saw one of these terror birds in the flesh, you'd think, oh yeah, that's a dinosaur. So they had terror birds in South America, and they were doing great. They were eating everything they could find. Again, the mammals were living in fear of these birds, but they were driven to extinction because a bigger badass, cats, saber-toothed cats, found a way to get down to South America. And when they did that, they ate all the terror birds, because you can be a terror bird and not hold a candle to a feline. So the cats ate all the terror birds. And then the cats went extinct because we don't have any more of these saber-toothed cats. They're also extinct. So what happened to them? We don't know. Maybe they ate all the terror birds and they starved. Who could be? So these are all the things we talk about when we talk about extinctions. And right now, the Earth is undergoing in the process of, however you want to say it, the sixth mass extinction. And much of that is attributed to humans. Humans are doing it. All the ways we do it. We did it with the dodo birds. We did it with the North American megafauna, probably. And these days, we just keep doing what we do. And sometimes we drive species to extinction on accident as a secondary function of something else we're doing, like when the peoples of Southeast Asia clear the forest so they can plant palm orchards, oil palms. They clear the forest and they plant oil palms. And the organisms in the forest can't live in the oil palm plantation. I'm trying to say this right. So without their habitat, without the trees and the fruits and all the diversity that used to be there, they have to go find other habitat. And there's a lot of concern now that species that were found in these forests on these islands are going to go extinct because we're clearing the forest so we can plant oil palm plantations. Now, we're not clearing the forest to kill the orangutans or the whatever else is the monkeys or the tapirs or whatever else is there, the elephants. We're clearing the land because we have commercial uses for the land, and destroying the habitat and the animals and plants that are in it is secondary. We're not doing it on purpose, but we're doing it, so it counts. And the sixth mass extinction is a result, an emergent property of all the stuff we do. Just as when we came to North America from Asia way back in the day, we just ate all the animals. We didn't mean to extinct them. We didn't like them and say, enough of that. And we killed them all. We just ate them. We were hungry. We ate them. Nothing personal. Just business. We're in business of eating. So that's how it happens. So yeah, an organism can go extinct in this stepwise fashion as it becomes smaller and smaller in population, and people and individuals can't mate and they can't reproduce, and they're pretty soon there's a few individuals left and then they're extinct. There's also this thing of, well, somebody just came in and ate them all. They were doing great. Someone came in and ate them all. Now they're gone. And the sixth mass extinction is us doing that. Not always eating them, but having other uses for their habitat, for the water they relied on. We could pollute the water and the fish all die. And if enough fish die, well, then all the fish are dead. And maybe we have extinct fish species as a result. There's all these different things that we do that we don't mean harm. We just mean to make money. And that's important. That's a thing. So we just make the money. And then someone tells us later, did you know that all the orangutans are extinct? I was like, what's an orangutan? You know those orange apes that used to hang out in the forest? Oh, yeah, I saw some of those. They're gone. Where'd they go? That was the problem. They had nowhere to go. We killed them by killing the forest. And no, are people going to care? No. They're just going to keep clearing the forest and keep planting their oil palms and managing their and whatever. Now, of course, the irony, the great, and you would even might find it ironic irony. Well, I guess all ironies are ironic. You may find it karmic, okay, that as we destroy habitat and as a consequence destroy other species and drive them to extinction, we are destroying our own habitat. You know, we live on this world and we rely on certain things to happen. We rely on the rain to fall in the hill so that fills the reservoirs, and the reservoirs have water, and then we let the water come into the cities and the communities and we drink the water. We rely on that. And you mess around with the world, with the earth dynamic system enough, you could change the weather. And all of a sudden there's not as much rain falling on that hillside, and that reservoir just starts to draw down, and pretty soon you have no water. And you didn't mean to destroy yourself. All you were doing was clearing a rainforest over here. But what you didn't know was, because how could you know? I mean, scientists know these things, but a lot of other people don't, especially if they're in business. They don't care about anything else. Why should they? They're in business. That's their business, is business. Though what they didn't know is the rain that used to fall on that mountaintop and fill your reservoir, that rain came from this rainforest over here. That someone else, maybe you, maybe someone else, maybe a whole other bunch of people in another country, they cleared that rainforest for their reasons, probably business, and all the trees are gone. And when the trees are gone, it couldn't create the clouds. The clouds would blow into your neighborhood, hit your mountain range, drop the rain, and create the reservoir that you got your water from. And you didn't know any of that was happening. All that gearing. Had no idea. However, now your reservoir is empty and you got no water. How'd that happen? It used to rain up there all the time. Hasn't rained up there in 10 years. What happened? You fucked up. You destroyed your habitat. That was part of your habitat. That reservoir up there full of rainwater, that was your habitat. You relied on that. That was your water. You need food, water, clothing, shelter. You need stuff. And now it's not there. Okay, can't live here anymore. So you're done. So you leave. So you're kind of like the orangutan who used to live in that tree and eat that mango and, reproduced and had everything it needed. And you cut the rainforest down and the animal left and went extinct. And now it's your turn. You don't have water. Okay, you have money, so you can bring in water on tanker trucks. Not the same thing. A tanker truck of water is not the same thing as, going to your tap and turning on the faucet and having water come out from the reservoir. It's not the same thing. So maybe you can figure it out. Maybe you can't. And this brings up a topic that I'm going to cover quickly, and then I think I'm going to quit for the day. Remember, all of this is about what is extinction. This is just what is extinction. I get into near-term human extinction, hammer and tongs in the next section. You may want to come back for that. I mean, if you really want a nightmare, if you really want to lose sleep, we're about to lose some sleep. The next thing I want to talk about is extirpation, which is a 2-bit word. Sorry, I had to use it because it's the one we talk about. Extirpation can be thought of as local extinction. Now, extinction has a meaning, and that means all the organisms are gone. But on the way to extinction, you have local extinctions. And this would apply, for example, to island species. If you have, say, the Galapagos tortoise, but the Galapagos tortoise lives on 3 islands in the Galapagos island chain. And you can have a local extinction of the Galapagos tortoise on one of the islands and still have tortoises on 2 other islands. So extirpation meaning local extinction, can happen when there's isolated populations, meaning the tortoises on one island can't easily get back to that first island to repopulate it. There's some barrier. For the tortoises, of course, it's the sea. But for other animals, it might be a mountain range or a river they can't cross because they don't swim. They're just a shore animal or a tree animal. They don't really swim, so the river is a sufficient barrier. And you can have extirpations. And that's not extinction. And it's really easy to overlook. So if you hadn't studied the Galapagos tortoises, and when you finally got there to study them, you only found them on one of several islands, you would say, oh, these tortoises are very interesting. They're found on this one island. Maybe you don't know that they used to be found on all three or all six or however many of the islands that used to have them. And so what you don't know is they're going extinct. And that may not be in your report. You would simply say, oh, we found these interesting tortoises on this island in the Galapagos archipelago. And you would write up and describe them. And nowhere in your description would it be, and they are endangered and going extinct, because you didn't know that they used to be found in these other places. Now they're not. And the fact that they're not found in these other places suggests something happened to them. What is it? A predator, a disease, a lack of habitat, a food supply that went away? Who can say? Humans found them, ate them, who knows? But in any case, what you don't know, because you've only just now found them and you found them in this one place, what you don't know is they're going extinct because they've been locally extincted in these other places until now they're found in one spot. Local extinction or extirpation is a process towards extinction that it used to have a large range but isolated populations. And when some of those populations went extinct, locally extinct, then the entire series of animals that are all related may end up being found in one place. And that's the last place. And if you lose them there, then they're extinct. But it was a stepwise thing of losing them here and here and here and here and here, and either not knowing that was happening or not caring. And one way you can reverse that is you could find the tortoises and you could say, hold on, what's special about this island? They could live on that island and that island over there too. So why don't we just take some of the eggs, some of the breeding pairs, and move them to these other islands and let them establish populations there? And then at the very least, we no longer have one vulnerable population where the whole thing might go extinct overnight. Now we have multiple populations that are in different places. And that's cool because now we have a little less of a worry that something bad is going to happen. And this, there's an entire science in biology of reestablishing populations in places where they could and maybe should be. And what you're trying to do is you're trying to prevent an accident or a disaster from just wiping them all out. You're reintroducing them to their proper habitat. And we see this a lot in wildlife biology. For example, all the wolves were driven out of the lower 48 states. And they only existed in Canada, the gray wolves. And then, because the wolves were gone, the populations of their former prey items began to take off. There was no controls. And, they issued permits to humans to hunt them, and the humans would hunt the deer or the antelope or wherever else was missing a predator, but they just couldn't control them. So there was a move several decades ago now, I don't know how successful it's been, to reintroduce the gray wolves back into these habitat where they had been driven out. And why they've been driven out? Well, because of business. The cattle and the sheep farmers didn't want to share the habitat with the wolves. They wanted every blade of grass to have a sheep on it, and they didn't want any pasture not to have sheep. So they put sheep everywhere, and the wolves discovered that, and they said, that looks yummy. And they came in and they ate the sheep. But every time you eat a sheep, somewhere there's a shepherd that says, oh my God, I just lost some money. And so they killed all the wolves and drove the wolves out of the country. And then they introduced new problems. Oh my God, now we have this other problem. And so they had to bring the wolves back, and people really didn't like it. The people that had sheep and cattle, they didn't like it. They were like, what are you doing? Bringing wolves back. We just spent all this time getting rid of them. And someone else said, yes, but you've screwed the pooch. Now the habitat is completely out of balance. They had to bring the wolves back. And there was all these protests and all these people angry about the wolves coming back. It's like, we have to have the wolves. They're necessary. They're a keystone predator. They're helping to control populations of other animals. And if they take a few of your sheep and a few of your goats or whatever it is that you're all got your undies in a bunch about, well, that's just business. Write it off on your taxes, okay? That's a thing. They reintroduced them. They used to be here. We drove them out. We were the reason they couldn't be here. And so they just told the farmers, shut the fuck up about it, and brought them back. Now, the wolves were in no risk of extinction. The reason we brought them back was because we needed the service of killing some of these prey species that they normally would keep under control. So that's a service. They provided that service. We didn't know it was important, turned out to be important. So we brought them back. We can reintroduce animals to extend their range, and we can modify our behaviors to find that acceptable, as we did with the wolves. And we could do it with any other animal. This is wildlife biology, and they're always doing reintroductions, right? They'll reintroduce wolves, but also they'll reintroduce mountain lions and bears and all these kind of things. It's generally predators, not always. They've returned the great bison herds. We used to kill the bisons. We call them buffalo, but they're not. They're a bison. Here in North America, we killed all the bison. The Indians were using the bison for food and resources, like the hides and the bones and things like that were all useful. And the Indians were using the bison. And so the white settlers who were at war with the Indians over business, basically, decided, hey, one way to get rid of the Indians is to get rid of their food supply. So the white people just killed the bisons, killed them all. There used to be herds of bison that were so huge they would just blacken the landscape with their bodies. Just you couldn't see anything for a dozen miles in all directions, just thick with bison, because they were eating the grasses, so there was food everywhere. Plus, of course, we wanted to use that land. We wanted to cut those grasses down and put in other crops. And of course, we didn't want stupid bison out in the cornfields and the beet fields and the wheat fields, trampling everything and eating it and whatever. We got rid of the bison. And we got rid of the Native Americans at the same time, but doing the same thing. And the bison were gone, and the Native Americans were gone, and the land was open to cultivation. We put the crops in the land. We made money, business. And, and then someone said, hey, that was dumb. We should bring the bison back. And so they found some tiny herd of bison someplace. And then they've been doing all this, rebreeding, and they're reintroducing the bisons to some of the national parks because that's where they used to be. We got rid of them for our reasons. And now we're bringing them back. We do that. Now, before I end, I'm going to mention something that's going to seem tangential, but it's not. So, as I've said, there are lots of people cogitating, thinking about the prospects, the possibilities, what if scenarios about near-term human extinction. One of the people that's been doing that is this guy you've probably heard of named Elon Musk. Elon Musk is a billionaire. And I don't know if it was a childhood thing or sometime when he was an adult, he just had an epiphany. He became worried about near-term human extinction. And the way he puts it is that humans need to be a multiplanetary species, and there's a lot in that statement. He'll say it all the time, and he says it the same way every single time. He doesn't say we deserve to conquer the stars. He doesn't say our destiny is the stars. He doesn't say the planets hold amazing amounts of wealth to be exploited. He's not saying it that way. He may say that in front of some people. But what he does say, and he's pretty consistent, I've heard him say this many times, humans need to be a multiplanetary species. That's interesting to a biologist. I don't expect anybody else to understand the importance of those words strung together in the way they are, but I'm a biologist, so I understand what he's saying. We need to be a multiplanetary species. So what was it like when the last of the Galapagos tortoises were on one island? They could have been on the other several, but they weren't. They were on one island. They were a one-island species. And what does that mean? That means that they're vulnerable to extinction. In fact, they may have been a multi-island species, but just all these extinction events have finally gotten them down to one island. That's it. That's their story now. All those tortoises are found on one island. They're a single island species. And I think what he's basically trying to say is that humans are a island species. We've got one planet. That is not to imply that we've been on other planets before, but here's where we find ourselves. One planet. Now, it's a big planet and it's diverse. We've got deserts and forests and plains and river basins and wetlands and oceans, and cold places and hot places. And, there's something for everybody, right? But we only have one planet. And when and yeah, you may not like this idea, you may not buy this idea, you may think I'm a kook, you may think that this is nonsense, but we got one planet. Now, if you have one planet and something bad happens, you run out of narrative, you run out of a story. And you remember how I started this lecture a little while ago? I was talking about how humans have had two stories already. You better start connecting the dots, my friend. Humans have had two stories. And that story, that history, is written on our DNA. We found it on accident, completely on accident, when we discovered that while there are modern human remains, this skull, this jaw, these teeth, these fingers, these hips, this knee, while there are modern human remains that go back 300,000 years, the human genome is 70,000 years old. And one explanation for that isn't that we started 70,000 years ago. We have an Adam 70,000 years ago and some Eve, or at least the metaphorical concepts being the same, 70,000 years ago. Is that we have two stories. And those two stories overlap 70,000 years ago. And the first story was whatever happened for humans from 300,000 years ago to 70,000 years ago. And that story ended. It ended. Basically, they went extinct, except not quite. Not exactly extinct. But whatever story had been written on their DNA up to that point ended. That's our first history, which we know nothing about because they didn't have tablets and they didn't have, obelisks and hieroglyphics and books and cave paintings. They didn't have any of that. And some cave paintings. They didn't have much history written down. Their only history would have to be written on their DNA. And that history was lost. Those individuals, those groups, however big those populations were, we have no idea because that entire history that should be written in our DNA, carried around inside of us to be discovered by modern science, statistical means, that history is gone. It's gone. It just vanished. Where did they go? We don't know. What happened to them? We don't know. Was it a predator? Were they eaten? We don't know. Did they lose habitat? Did some aliens cut down all their forests and leave them with nowhere to live? We don't know. They died. Where'd they go? We have no idea. All we find are their bones. And written in our modern DNA is our history, not theirs. Not theirs. They're gone. And that means, according to one accepted theory, that we came this close to extinction, so close to extinction that whatever came after that event, whatever that event was a whole new thing with its own history. This started 70,000 years ago. We've been there. We have been there. You have been there. In your DNA is the history of how you were there. Just this many. Tiny number of people. Now, they were tough. They were scrappy. They were innovative. And from that metaphorical Adam and Eve, came all of this. And now we are 8,000 million people. We are so many that we cause other organisms to go extinct on accident. Pretty much on accident, just doing business, just making money, making products that people want to buy. And now all these other animals are extinct and the forests are gone and the rivers are polluted and the birds are falling out of the sky and whatever. Didn't mean that sad amount, but I'm not going to stop. Okay. We're doing that now. The sixth mass extinction is what we're calling it. And that's us. We're doing all that. But that happened to us a long time ago, 70,000 years ago, 70,000 years ago. That was us. Tiny number of people. Somehow started over. Now, I came back to that story because I was just now talking about Elon Musk. And Elon Musk is saying that humans need to be a multiplanetary species. And why would he say that? And why would he say that right now? Because he's not a dummy. He knows. We were tiny. We were just a few people, an almost literal, but still metaphoric Adam and Eve. We were so few. And from that came all of this, originating in Africa, which was our last habitat. Everything else we were gone everywhere else. And he's saying, now, I haven't talked to the man, but I think I know what he's thinking, because he's no dummy. I'm no dummy. And I'm an evolutionary biologist, but he knows something about what I'm talking about right now. And what he's worried about is that we are an island species. And our island is the Earth. And we don't have any other habitat. And we need to be a multi-island species, like the tortoises. There's other habitat maybe we could occupy. It's not really easy, but maybe Mars, maybe the moon, I don't know. And maybe other planets and other star systems, right? Now we're getting into Star Trek. But anyway, it's a thought, right? Now it's a thought that we could be a multiplanetary species. And why would that be the case? Because if you're stuck in one place and you've only got one story and your whole history is all tied up in this one rock, well, then you could go extinct because you don't have another rock. You don't have another island. You don't have another forest. You don't have another story. You're on this one place and you could go extinct. Now, how do people go extinct on a rock the size of the planet Earth? Something happens to the Earth system. It's our habitat. And, some of us live in the deserts and some of us live in the highlands and some of us live in the river valleys, but we all live on the Earth. And the Earth has a whole set, even if you're in the desert, there's still conditions on Earth that make that habitat for some people. I mean, there's oxygen in the air and the temperature, it gets hot and it gets cold, but it's within a range, right? And there's other resources, right? There's water in places and there's food in places and you can have camels or whatever. And you're living in the desert or you're living near the desert and it works out. So it works out for you. And everywhere on Earth, there are people living in every possible place and it's working out because it's all within a certain range. There's a certain amount of water. There's a certain amount of heat and cold. There's a certain amount of food to eat. Everything is just like all within a range. And so it's all suitable. And we figure it out. And maybe we wear more warm clothing in some places, but that's adaptation. And maybe we have clothing for hot places or no clothing at all. Maybe we live in jungles and it just rains all the time. We don't have any clothing. And we're eating the fruits and we're eating the monkeys or whatever we're doing. And we just figure it out. But the point is the entire planet is suitable for us. Every place except places like Antarctica. And the middle of the Gobi Desert, there's a few places where humans can't live, where it's really extreme. But you can go there and find out why it's extreme. It's just too fucking cold. There's no food here. There is water, but it's all frozen. You just can't live here. Except that you have a lot of science and technology to make it feasible. And there are people that live now in Antarctica. There are bases down there that are continuously inhabited by humans. But they brought all their technology with them to fight the cold and to melt the water and have, melt the ice and have water. They brought all their technology for that. And so they figured it out. But by and large, Earth doesn't need figuring out by humans. There's plenty of places, but there's only one Earth. And so when Elon Musk comes up and says, humans need to be a multiplanetary species, he's saying all your eggs are in that one basket. Now, you don't have to look too far for an example of what happens to a species when they're not multiplanetary. The dinosaurs were not multiplanetary. And for them, when the Chicxulub meteor hit and wiped out the dinosaurs across the entire planet, that was it. They only had one story. If there had been dinosaurs on Mars, we would have found dinosaurs on Earth. Oh, look at these extinct species. And then we would have found them on Mars doing fine. And we would have said, oh, they're the same thing. How did they get on Mars? How did they get to Mars from Earth? Or how did they get to Earth from Mars? We don't know. Dinosaurs with spaceships. Who knows? Okay. But in any case, if we found them dead on one planet and still existing on another, we'd say, well, that's nice. They were a multiplanetary species. And then we might even say, hey, if they're still on Mars and they're the same organisms as used to exist on Earth, we could reintroduce them on Earth, like we talked about reintroducing the tortoises to different islands. So let's make the dinosaurs a multiplanetary species. How about that? We'll just go to Mars, bring some of the eggs and the reproducing adults and put them on Earth, put them in appropriate habitat, and then we'll have dinosaurs on two planets. That's cool. And then if there's another meteor that hits one planet or the other, Hey, we still have dinosaurs. We can repopulate back the other way. So by being a multiplanetary species, the dinosaurs wouldn't have gone extinct because a meteor hit the one place they could live, Earth. Now, another meteor, the same basic meteor that extincted the dinosaurs, could hit Earth tomorrow and extinct the humans. It happened to the dinosaurs. It could happen to the humans, right? Uh, I don't think it would happen to the humans. Again, that's another discussion for later as to why we can't go extinct. And I have reasons for that. I mean, they're not, they shouldn't give you any comfort, but there are reasons why humans probably don't go extinct regardless. So maybe a meteor wouldn't destroy all of humanity, but it might. And there's something else that could destroy all of humanity, which is the subject for another video, and that's global heating. Again, the reason we can live on this planet and in most of the places on this planet is that the parameters of physics as they operate on this planet are within certain acceptable ranges. It's never too hot, it's never too cold, it's always kind of in this range. And in the places that are too hot, we don't live there. In the places that are too cold, we don't live there either. So there's this, up here we can't live, down here we can't live, but there's this range and variation where we can survive with adaptations, mitigations due to technology. So if the Earth heats and it heats enough, then the range in which humans find themselves might end up here. And that could be unsuitable. It still varies a little bit. Summers are warmer than winters, but it's so hot all the time that it's just not suitable anymore. That's it. And we can't live on Venus. Venus is like 800 degrees Fahrenheit or something. It's hot enough to melt lead. We can't live there. Probably we could if it weren't for that, but it is that way, so we can't. And Mars is, devoid of water, and it's like, I don't know, minus 20 degrees all the time. We can't live there either. It's too cold. It's too dry. It's just not suitable for us. So we don't live there. And, of course, we couldn't get there earlier, but we can get there now. And if we got there now, we couldn't live there. So right now, we're just not a multiplanetary species. There are no suitable habitats other than this one. That's all we got. Earth is all we got. And there's plans to terraform Venus and plans to terraform Mars and make it more like Earth and make it more like Earth and less like it is now, whatever. Okay, you can have all that. It's all that Star Trek baloney, flat Earth stuff, whatever you want to do. Have all the conversations you want, write it up in the book. Maybe I'll read it. But right now, we're a single planetary species. And Elon Musk thinks that's a bad idea. And if he's thinking about near-term human extinction, he's got a point. Are we going extinct? Could we? Why would we? And how would that happen? What are the steps? What should we look for? What's going to happen to us? And we're responsible now for the 6th mass extinction, cutting down the forests, polluting the rivers, eating all the things that can be eaten. And we're killing species left, right, and center. And could that be what takes us out? Do we just kill so many other things that we die? And it wouldn't be because of karma, and it wouldn't be irony. It would just be, we've changed our planet. The one planet where we could live, we're changing it. And what if we change it outside the parameters that are acceptable for human life? Could happen. Will it happen? Well, I guess that's the later video, right? So today I talked about what is extinction. I just felt like I had to define all these terms and give you all the examples that are relevant, because they're all relevant to our situation. And they're all relevant to why people are running around right now saying near-term human extinction is a thing. And it's also relevant to why Elon Musk is working so hard on SpaceX and wondering in his public statements, how can humans become a multiplanetary species? All this is tied together. And you think it's not, and you think it's just mad people, bringing down God's wrath or something, doomerism. It's not. It's science. It is. I just gave you an hour and 13 minutes of science. That is all science. Chock-a-block. Big words, big ideas, all these examples, all this shit you've never heard of. It's all science. All of it. Every syllable of it. 1 hour and 13 minutes of science. What is extinction? Next time. Why? Why are we talking about near-term human extinction? Why are we nervous that we're a single planetary species and not a multi-planetary species? Why are people getting all wrapped up about this? That's the next video. Again, like, subscribe, and if you feel like this is a valuable resource to you, in the description is a link to my buy me a coffee. Feel free to buy me a coffee. I'll appreciate it. I really will. And everything you want to do for me, likes, comments, everything else, it's appreciated. And spread the word. Get more people on here. This is science, baby. We're doing science here. You got it? We're doing science. It's savage science, and I'm a savage. I'm an animal. But hey, it's all science. And you're not going to get savage science anywhere else. You're going to get it here.